Probably page 7 or 8, maybe. Keep going. Oh, 10. There we go. Page number 10. All right, first thing first. Can anyone figure out what that hideous drawing is? That is a bicycle with a person on top of it. All right. So one of the easiest ways to explain what we're going to do is to start by just talking about the reaction that we could write if we were going to make a bicycle. Now, there's a lot of parts to a bicycle. We're not going to label them all. But there are 1, 2 wheels, right? All right, and we know it takes wheels, plus we're going to call it a frame, and that will make a bike, which has 2 wheels and 1 frame. Who's with me so far? Is that balanced? No. How many wheels are on the bike? 2. So how many do I have to put in the first place? 2. So that's why we would put a 2 there. We wouldn't put them together because the wheels aren't connected to anything, right? They are alone. And then we connect them to the frame, and we have a compound or a thing with more than one thing stuck together with 2 wheels and 1 frame. Is that easy enough so far? All right, what we're going to do, and I know I look like a noob with these whatevers, but I don't care. What we're going to do today, and we kind of hinted on it, is we're going to say, all right, well, if I have 75 wheels, how many frames will I use, and how many bikes can I make? Does that seem that difficult? Everyone, if you have 70, you want me to make it an even number? Would that, okay, sorry. Let me make that an even number. How about we say we have 50 wheels? How many bikes can you make? 25. How many frames would you use? 25, right? Because look, you have twice as much as you do frames, or you need twice as much as you do frames, and you will make 1 to 2 or half as many bikes as you have wheels. Who's with me so far? Raise your hands. Okay. The same thing works with sandwiches. Takes 2 pieces of bread and whatever you put in the middle, but it's ratios, right? These are just like recipes for food, and we can upsize or downsize the recipes. Anyone ever done that? Okay, that's all we're doing. Now, it will get a little more complicated because eventually, this thing's just in the way. Whoa, what did I just do? All right. What we're really going to do, it'll seem weird, but we're going to change this and say if I have 200 pounds of wheels, how many pounds of bikes can I make? Now that's not a unit we're used to working with, right? But we could do it. We would need to know what little ratio. Anyone know? All right, we need to know the weight of the wheel. And we need to know the weight of what? The frame. Well, we don't really need that. We would if we asked that. But we're just asking for the bike right now. And we could find those ratios, right? We could put it on a scale and measure it. It's a little bit weird. But in chemistry, we're not making bikes. And we don't have to put things on scales because we have that thing right there. What does that tell you? That's going to give us the mass of atoms. Okay? So we're going to combine what we've been doing of balancing a chemical reaction. Balancing the chemical reaction will find the ratios I need. We're eventually going to use the periodic table to find the masses of the stuff I'm going to need. And then we're going to say, all right, you have 50 grams of sodium. How many grams of salt can you make? It's not that hard if you just do it step at a time. You with me? Turn to your lab partner right now and say, it's not that hard. We'll do it together. Ready? Go. Now, who feels like their lab partner didn't really believe it? Okay, good. Everyone's in then. All right, let's look at the notes on the top of page 10. And there's, I don't know. Sometimes I wonder if I should just delete these. But here we go. Balanced chemical equations give us proportions that can be used for predictions. So in this equation, we have 2 sulfur plus 3 O2. Is that what it is? Or plus O2. Or is it 3 O2? All right, thank you. 3 O2 goes to 2 SO3. Is that the right one? Okay. We'll get the notes in a second. But these numbers right here, these are the ratios in my recipe to make SO3. Just like you need, if you said 2 dozen eggs, 3 pounds of flour, you could make 2 dozen cookies, something like that. It's just a simple recipe or ratio. All right, but these ratios, they can be used for predictions. We have a ratio of S to O of for every 2 S's there are 3 O2s. It's just a ratio. You just take the number and just make a fraction out of it. All right, and we can do that with any of the pairs that we want. Now you do need to know, we said this yesterday, when we've been putting coefficients, what word do these really, what are they? Moles, which is a big A number, right? It really means you need a lot of S to react with a lot more of O2 to make the same amount of SO3 as you did S. But these ratios are going to help us to make predictions. And please do it slowly and in my way and we'll be fine. So here we go. If 2 atoms of S are used, how many molecules of SO3 can be made? So look here, it's just testing this ratio. If you have a 2 here, what do you have here? A 2. All right, the next one, if 2 dozen atoms of S are used, how many dozen molecules of SO3? 2. Look, you can put whatever number on the planet you want right here, and it will always be the same over there, because a 2 to 2 ratio is the same as a 1 to 1 ratio. Not bad so far. Okay, next, if 1 mole of S are used, how many moles of SO3 can be made? 1. No matter what you do to S, by this ratio, SO3 will be the same. Okay, we're going to switch it up. If this is a 3, which it is it asking that one again? All right, if this is a 3, what's that number? A 2. Now, it doesn't ask it, but let's do it. If this was a 6, what would that number be? A 4. Whatever you do to this number, you have to do to that number. I just doubled the one, so I have to double the other. So they're just relationships between them. All right, then, it says by using moles, yay, and the molar proportions found in a balanced chemical equation, we can predict the amounts of chemicals in a reaction. That sentence is pretty much the definition of what we call stoichiometry, which is what we're going to do the next 3 school days. So when you go home tonight, and anyone says, did you learn anything? Say, yeah, I learned stoichiometry. We're hardcore stoichiometrists. All right? Most of your parents might ask what that is, so be ready to say it's using balanced chemical equations and their molar relationships to predict how much products and reactants are formed and used. Bueno? Is anyone's parent a chemical engineer? There we go. They know stoichiometry like a boss. Unless they're like a manager now, and they forgot it because it was 10 years ago. All right, for a chemical engineer, it is super important to know how much of this you're going to make, because you don't want to buy too much of that or too much of that and have excess, because that's a waste of money. The most common importance for stoichiometry in our town is airbags. It is important that the exact right amount of powder that needs to be ignited to inflate an airbag before your face hits it. All right, here you are. You're about to hit that thing. If they put too much, it'll be like running your face into a cement wall. If they put too little, then you're going to run into the metal part of the steering wheel. It has to be exactly the right amount of powder. The only way to know the right amount of powder to fill this volume, it's about 30 liters-ish, is to know the stoichiometry, the relationship between what is there and what will form. Like, it governs all of your life. You just don't even know it. And you don't care, and that's fine. It's my job to try and help you care. Okay, so here we go. Oh, we still have this. What are the molar proportions given in the equation above? Sorry, I got rid of it. 2S plus 3O2 goes to 2SO3. So these are just the ratios. Is it just three of them, right? So the first one under it says moles of S. So we're just putting the numbers. How many moles of S are there? 2 mole S. What's the denominator? Mole of what? Of O2. What's in front of O2? 3. So my ratio is 2 to 3. What's the middle one? What's the moles of what? SO3. And what's in front of that? A 2. What's the bottom one? All right, and that's a 2. You could reduce that to 1 over 1 if you want. It doesn't matter, because in math, what's 2 divided by 2? 1. What's 1 divided by 1? 1. So if it is reducible, you can, but you're not required to. Then over here, moles of what? On the top? SO3, and what's in front of that? A 2. And then the last one is moles of what? Whatever, that's a 2, and that was a 3. So there are your ratios of one thing to another. Okay, you just literally find what it's asking, go to the equation, and write the number in front of it. Okay, the first example we're going to do is we're going to teach you how to convert from moles of one thing to moles of another. So will you quickly balance as fast as you can copper 2 sulfate plus aluminum. You've done this before, but it's just right there in your notes. Is CuSO4 written first? Okay. Is Cu first, or no? It's aluminum, probably, right? Aluminum. All right. Raise your hands if you already have it balanced. Okay. Shut this door. All right. So in stoichiometry, the first thing we always have to do is to do what? Balance. Now, if you suck at balancing, but you get the math, that's fine, because on the test, everyone you have to do math on is already balanced for you. So we put a 3 right here, because there's 3 SO4s. That makes 3 coppers, so you got to put a 3 right here. You with me so far? There are 2 aluminums, so you put a 2. That's where you started, so you put a 1. Who had it right? Okay. Now the question is super simple, and it goes back to trimester 1. We're going to use a picket fence to do this, and you can roll your eyes. You did roll your eyes. Impressive, Bullard. Just trust me. These get a lot harder. At first they're easy, but they get a lot harder pretty fast. So it says, if you have 6 moles of aluminum, what do we always do with our given? Anyone remember? Put it in the where? Top left. So, don't, I'm going to hand out U's like crazy today. Who exhaled? Oh, I heard it. I heard it. Probably Shani. She's always hardcore. 6 moles of what? Aluminum. You always take the number and unit of the given, and it always starts at the top. Now, did this come from the problem, like the equation? No, we're changing that, and we're going to find what happens if we change it. All right, so we start there, and then it says if you have 6 moles of aluminum, how many moles of copper can be made? All right, so please look at me. Mole of Cu. That's what I'm looking for in my answer. All right, now, please look. I know that a lot of you are smart, and you're already bored, and you're already done. The unit on the top always goes where? Over 1 and down 1. Okay? The unit that's here always goes down and over. So mole, Al. And then the unit at the end is always the unit at the end. It's been a long time since I said these stupid things. But remember, the unit at the end is always the unit at the end. All right, now we need to find the numbers that go in front of these two words. Where do we find those numbers? From the balanced chemical equation. So what goes in front of Al? A 2. What goes in front of Cu? A 3. So now we just do the math. What is 6 times 3? 18. And then we divide that answer by 2. So the answer is 9 moles of Cu. Yes? You can, but you can't do that in your head once we start doing the other ones. They get longer. Because the picket fence is going to look like this in 2 days. And if you can keep track of all that and do the picket or the math on the periodic table, then you're a genius. But I haven't met anyone that can yet. But yeah, of course, you can do that one. Very simple. Okay, so moles to moles. Please look again. We take our given and put it right here. We take the unit of the given and we put it on the bottom. We take the unit of what we want, put it on the top, find the numbers from the balanced chemical reaction, and then go from there. Okay, turn to your homework and let's do a couple of these easy ones before we get harder. So the first one is number 36. Will you please just balance? N2 plus O2 goes to NO. I think you can balance that one fairly simply. And then, I know it's simple, but if we learn things while they're easy, then they're not hard when they get hard. All right. N2 plus O2 goes to NO. That just needs a 2 right there. We're done. What the freak? All right, there we go. Now these are just ones, right? So all the math is going to be simple. You can do all this math in your head most likely. Okay, so I take my picket fence and I say, it says how many moles of nitrogen monoxide? So I'm solving for moles of what thing? Which one of these is nitrogen monoxide? No, right? Nitrogen monoxide. Now, what do I know about the unit at the end? Please say the stupid things with me. The unit at the end is always the unit at the end. I know these seem dumb, but they will help you a ton in the long run. All right, now let me continue to read the problem. Can be made using 0.5 moles of oxygen. What do I do with my given? Put it to start. 0.5 moles of who? It's 5, sorry. 5 moles of which one? Oxygen. Please, 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 everyone look at me right here. If you don't put that right there, you're going to get these wrong. Like, you can do it without putting it, but you get lazy. Like, oh, I got this. But look, if you don't know this exact unit, then you don't know the exact unit that goes down there. And you're going to raise your hand, and I'm going to come help you, and you're going to say, I don't know what goes down there. And I'll say, it's because you were lazy and you didn't write what was up there. Please be OCD and put these. Most of you cannot do these without being very structured. All right, so what comes down here? Moles of O2. Once again, please write out the identity of the thing so you don't screw up. All right, what's in front of NO? 2. What's in front of O2? 1. That sure took a long time to just multiply something by 2, right? I am aware of that. We're learning the process while it's easy, so that the process is easy when it's hard. Look at me that way ever again.
Okay, next. Will you balance 43? Sorry, 43. Where did that come from? Whatever. I have no idea where that number came from. Will you balance 38? I will tell you right now, you probably need some help. Is it HCl first or NaOH? Okay, you're going to hate this one, by the way. I got to change this. All right, this is what type of reaction? Anyone know? It's a double replacement. So H will hang out with the end of that one, and Na will hang out with the end of that one. So we have HOH plus NaCl. We would balance +1, -1, +1, -1. Oh, it's already balanced, which means what you're going to do is a complete waste of time, but please do the process. Ready, set, go. So here we go. What was the given? Is it 25 moles of something? 25 moles of who? HCl. What should you put down there then? Mole of HCl. What's it asking for in the answer? Mole of NaCl. The answer at the end is always the, I shouldn't say answer, I meant unit, but yeah, the end and the end are always the same. Hey, 1 and 1, I can do this math in my head. 25 all day long. No wonder I'm in the running for Teacher of the Year. Month, week. What was it? Month, yes. All right, who had 25? All right. There's one more. This one's harder. Would you like me to help you with the chemistry? Wow, Isaac, then just do it yourself. Everyone else. This is a combustion reaction. This is a good practice. I think it's the last, no, there's one more, but it's the second to last combustion in practice before you test. And combustions are the only one that there's two of on the test. There's one of every style to balance, except for there's two for combustion. So here we go. Gasoline is C8H18. All right, then it's a combustion, so you react with oxygen. It produces CO2 and H2O. Will you try and balance that yourself and then do the picket fence yourself? It's a combustion. There are some things that will help you. A combustion reaction, you start by putting a 2 in front of the first thing. Then you balance carbons. 2 times 8 is 16. Then you take the number with H and you put it in front of water. So that's an 18. And then you have to do some pretty big math. 16 times 2 is 32. Plus 18 is 50. Divide that in half and you end up with 25. Okay, there's the chemistry. If you were struggling there, that's fine. Now try the picket fence if you haven't already. So you take your given is 25 moles of something, wasn't it? Is it 25? Yeah, that was the one before. It's what? 150. 150 moles of octane. So that's that, C8H18. So what does that mean about the unit down here? Tell your lab partner now. It's the same. Moles, C8H18. All right, and then the question's asking for moles of carbon dioxide, isn't it? All right, mole CO2. The unit at the end is always the unit at the end. So then you come up to the balanced reaction. You find a 16 in front of CO2. You find a 2 here. Now, in my calculator-wise, I would just reduce this to 8 over 1. And then I would do the math and get 1200. Is that right? This is the answer, by the way, to roughly the average car, how many moles of CO2 it produces when it drives to Salt Lake. That's a lot. If you times that by 22.4, I can't remember what it is, but that's how many, do that for me, 22.4. What'd you get?
This is how many liters of carbon dioxide the average car gives off as it drives from here to Salt Lake. That's a lot of carbon dioxide. And I just can't believe that the entire atmosphere isn't carbon dioxide now. That's one car. All right. Easy enough. Let's go back to our notes. And we're going to take our picket fence and we're going to make it longer. And we're going to need our periodic table to do this part. My eye is itching so bad. So let's do a quick review real quick. It's kind of redundant. But you're going to need the middle, because we're going to go back to looking at the molar masses. The molar masses are the bigger of the two numbers. So for instance, sodium, what's its molar mass on the far left? 23. The 11 is its atomic number. Everything you're going to do in this lab book, we're going to deal with the large number. You okay with that? All right, now that 23, we haven't stressed a ton, but we have a 23, Na, an 11. For this lab book, I couldn't care less about the small number. But look, this 23 is not just 23. It has its own unit. Do you remember from part A, chemistry A? It's 23 grams per what? 1 mole. Are we all right with that? We're going to repeat this a ton today. Whenever we find a number up here, it's grams over 1 mole. Grams per 1 mole every single time. And we're going to use that ratio in a picket fence. Now, it wouldn't matter if I wrote 1 mole for every 23 grams either. The picket is reversible. Who's with me? Okay, so whenever we find this big number, it is a proportion of grams per mole or mole per gram. All right, let's do this. So the first thing to do is to balance. FeS plus HCl goes to H2S plus FeCl2. I just said HCl. What FeS. What's the first part? All right, thank you. So we have to balance. Hopefully you're already done with that. If there's 2 H's on one side and 2 Cl's on one side, you can fix that by putting a 2 right there. 2, and then 1, 2, 1, 1. Who had that right? Raise your hands. Okay. Now, we're going to make a picket fence, but it will be longer. It's going to require 2 vertical lines instead of just 1. And I'll show you how to know that eventually. But let's just read the problem now. The problem says, if 1.8 moles of HCl, what do I always do with the number and unit I'm given? Tell your lab partner. All right, you put it in the top left corner. And was it 1.8? I should have a better memory. 1.8, is that right? Moles of something? Of HCl. All right. And I'm going to continue to read the problem. If 1.8 moles of HCl were used, how many grams of H2S should we have? So here we go. Grams H2S. Okay. Am I solving for moles now? No. So we follow a similar process, but it's not exactly the same. So please look. We have moles of HCl. Tell your lab partner what you always do with a unit that's up and over. You move it to the right and to the bottom. So what's on the bottom here? Moles HCl. And, excuse me, what's in front of HCl? A 2. This 2. Okay, now,
There's nothing else here. Please follow this process every time. There's nothing to tell you what goes there. Some of you might know, but some of you might not. There's nothing to tell you what goes there yet. So we start at the beginning, we start at the end, and then we're going to meet in the middle underneath the old Georgia pine. That's not really a very good pine tree, and if you don't know what I'm talking about, don't even worry about it. Okay, so we've been saying this a lot. What do we know about the unit at the end? It's always the unit at the end. Grams of H2s. Okay, now, before I erase this slide, I said anytime we find grams, it's what? Okay, it's the atomic mass, but what's its other half? Grams per 1 mole. Always. Like there's a few things you just got to commit to memory. Anytime you have grams, it's always per 1 mole of the same thing. Now please look at me. Please look. Are we all okay that this unit that's here goes down and over? Okay, so look. That means that whatever unit is here goes up and over. So what's in this middle box? What about it, though? Be specific. Mole, H2s, and where do I get the number from? From right here? There's a 1. Okay, so the last thing I have to do is find this, and then I can do math. How do I find the grams of H2s? Oh, that goes back. Periodic table. I need to know what the mass of H is, which is, where'd it go? It's 1 and 1, so whatever, it's 1. But there's 2 of them. Oh, good, Alec. And then, sorry, that was rude. That was rude. What's that? Good. What's the mass of S? 32 and 16. All right, so we couldn't care less about these bottom numbers. So we add these parts. 1 plus 1 plus 32 is 34. And it's not just 34. It's 34 what? Grams, but not just grams either. Grams per 1 mole of that thing. Oops, H2S. Okay, so coming back up, that's the number, 34 grams of H2S. Now, a lot of kids can do this, and then they screw up in their calculator. This one really is fine. No, hardly anyone would screw up here. We're going to take 1.8. You multiply everything on the top. 1.8 times 1, screw that. 1.8 times 34, right? Then divide that answer by 2. Do that in your calculators if you would. All right, my lab partner got 30.6. Did anyone else get that number? Okay, does anyone need a calculator? Well, I'm going to walk and get the box anyway. If I had a hoverboard, I could have just rolled over and got the box. Whatever. Okay. Who thinks that they get this? Raise your hands. Okay. Let's do one from your homework now. Anytime we have grams in the problem, we're always going to have to go to our periodic table. So the one in the homework we're going to start with is number 40. Mg plus O2 goes to MgO. You do the chemistry real fast. So we always start by balancing. All right, if there's 2 O's, what do you have to do over here?
Put a 2.
Thank you. Put a 2. That makes how many Mg's?
2. So what do you have to put right here? A 2. Then, did I do anything that affects the O's? No, so it's just 1. Okay, now we do it piece by piece. I'll let you try for a couple minutes, and then we'll do it together. Start with the loner, go as far as you can, then go to the end, work your way back till you meet in the middle. All right, let's do this one together. This one's the reverse of the last one. Did anyone notice that? The first one, looking back, I gave you moles and I asked for grams. In this problem, what am I doing? I'm giving you grams and asking for moles. So this is why it's important to just learn the process. Don't memorize anything. Just learn the process on how to do things. So what do we always start with? The given. In this problem, it gave you, was it 35? 35 grams of just mg. Okay? I can do some stuff from here. Please look. If you get it, fine. If you don't, you need to look. This unit always goes where? Down and over. So grams of mg. In my picket fence, anytime I have grams, it's per what? 1 mole of the same thing. And now look, if moles of mg is right here, what do I now know is over here? Mole of mg. Okay, then I'm stuck, so now I got to go to the back. What am I solving for? Mole mgo. What do I know about the unit at the end? It's the unit at the end. Thank you. Mole mgo. Now, I got to find the 3 values that I need. MgO, right here, that's a 2. Mg, that's a 2. So mathematically, that step is useless. Chemistry-wise, it's really important. All right, so the last thing is to go to my periodic table. I find Mg, and it's 24 and 12. I don't care about the small number, so this is a 24. Math-wise, you should. If it's a 2 and a 2, just don't do that step. So it's 35 divided by 24. One point what? 45? Okay, maybe a little trickier because it was the reverse of the first, but the process is still the same. I wrote a song about doing stoichiometry. Are you ready? Follow the process, follow the process, follow the process, and you won't get it wrong. I don't remember the rest of it. What's that? Yeah, I totally made that up. Even the flat baritone kind of off-key delivery. All right? Now, what I mean by that really is if you always follow this process, what the process is starting with the given. The number and unit of the given. Always taking the unit down. Finding how the unit can help you get here. If you get stuck, then you use the answer at the end to go the other way until you have some magical meeting where everything is lined up. If you do this slow and the same way every time, you'll never get one wrong. All right? Unless you use your calculator incorrectly. The next problem down, number 41, is actually on the top. Like the part is there, but the reaction's on the top of the next page. So it's Li plus HOH. Goes to LiOH plus H2. So we're solving for moles of H2.
We're probably given grams of Li. Is that this one? $10 grams of lithium. All right. So see if you can set that up before the bell rings.